Okay guys, so I just want to show you the my current best, fastest solution for the sequence peak detector. As you can see, 256 cycles. The main reason I want to show you this is because I'm looking for making it faster, and I hope that somebody in the comment sections will provide some great insight. Okay, so here's the code. I'm gonna explain it, but let's just make sure that this thing actually works. Ta-da! It does work. Yeah, it's not the shortest. It's not using the smallest number of nodes, but it's pretty fast. Unfortunately, not the fastest, and that's why I'm looking for insights, because honestly, I'm at the end of my rope here. However, let's see how this thing works. So the two separate paths, one for calculating the minimum, the other is for calculating the maximum. I'm gonna explain the maximum first because that's simpler. So the maximum path is the one that is on the right. These three nodes are the ones that calculate the maximum for each little sequence. So how does this work? Obviously this is nothing but just handing out the input values to the left and right paths, and these three nodes are the ones that calculate the maximum. The other path obviously calculates the minimum. I think the main insight that allowed me to speed it up to this point, at least for me, was that I wanted to keep, and this was the starting point of behind this organization, is that I wanted to use the accumulator of a node for the current maximum. I didn't want the current maximum to be, in the backup or somewhere else. I want it to be in the accumulator, and that's it. I wanted to just be able to say, send me the current value, and I'm gonna just immediately compare it to the current maximum. That's what I wanted to do. Okay, so for that purpose, what I had to do is I had to well, let's see. So what is the problem with this? Okay, you're saying, okay, fine, you're keeping the current maximum in the accumulator in some node, but as soon as you do the comparison to the incoming value, which is this is it, the incoming value is coming from the top node, I just subtracted from the current maximum. You're saying, fine, this is fine, but the problem is you're destroying the maximum. And that is true, so we have to be able to either restore it if the new value is smaller than the previous maximum, or we have to store the new value if that happens to be the new maximum. So to achieve this, basically we need the current value twice. We have to repeat it, and that's basically what I'm going to call the preprocessor node does, this top node. So, okay, the new value comes in, we send it to the right node, this is a preprocessor node. Okay, it stores it in the accumulator. Let's ignore this, because if it's not zero, let's ignore what happens if it's zero, but for now, if it's not zero, this means we are inside the sequence. We jump to this label inside the sequence, and all we do, so this is a simple case, just repeat it twice. We send it twice to the comparison node. That's it. Value comes in, we put it in the accumulator and send it twice. If it's not zero, the current value is not zero, that's it. Okay, so this is great because right now the current maximum is in the accumulator. We subtract. The current maximum is in the accumulator. We subtract the current value. If the result is less than 0, right, if it's negative, that means that the new value was greater than the current maximum. Fine, which means we have a new maximum. And what is the new maximum? Well, the current value, which is great because we are just sending it again. And so what you have to do is just store it. And we do that. We store it in the accumulator. The current value is being sent from the top. And, okay, so why do we send it down immediately? Why are we waiting for 0, right? So this is another trick. So I realized that this little guy cannot check for 0. It's because then it's just too slow. So that means that every time it updates the maximum, it's going to send it down, right? We'll see how what happens in the post-processing node. But for now, let's just assume that this is all we do. Now, you can see immediately that this thing just works. I mean, this comparison node, as long as values are coming in, it just compares them to the current maximum and then updates it. Okay, well, what happens if the result is not negative? That means that the current value was less than or equal to the current maximum. That's fine. All we have to do is restore the previous maximum, which we can, because we subtracted the current value from the maximum, so all we have to do is add back. And we can do that since the current value is being sent to us twice. So we just restore it by the previous maximum by adding back the current value. So this is great. This is great. But now, I mean, most of you probably start to think, okay, fine, but how do you reset this? I mean, how do you reset the maximum? You just keep updating it, and I don't see where you check where this whole thing is 0, and how do you make sure that you're not calculating the maximum over all input values, not just for a little sequence? So this is the second trick, so to speak, which is resetting this little thingy without it actually realizing that it's being reset. Because obviously this little middle node does not check for 0. So how on earth does it know that it has to reset the maximum? And it does have to reset the maximum, obviously. Otherwise, this whole thing does not work. So this is where the preprocessing comes in, because the preprocessing is the little guy that checks for 0, right? So here's the input value. We put it in the accumulator, and the preprocessor says, okay, is it 0? If it's not 0, we already see what's happening, nothing special. If it is 0, however, let's see what we're gonna do. So I use two special values here and try to explain why. So I'm just gonna send down 100. So why is 100? 100 is a magic number, but it just happens to be greater than all possible input values that are in a sequence. So in theory it might have been 999, but I looked at the input values and then for some reason they're all positive and less than 100. I don't know why this is, but all input values in all sets, in all tests have this property, so I'm just sort of exploiting it. But basically all I have, it can be 100 or 110 or 200, it doesn't matter. What matters is that it's greater than all possible values. So why I'm doing this? Because I'm sending down a big value, so I know that the middle guy is going to take the new max label, okay? This branch. And when it takes this branch, it's just going to take whatever I'm sending to it next and put it in the accumulator. I mean, under normal condition, I'm just sending the same value twice, but I don't have to, right? This is the other insight I had. I don't have to. I can send you, okay, here's the new value, and this is big. And then, okay, good. Now send it to me again. And oops, I'm sending you 100. Sorry, I'm sending in 0. So basically, I'm just resetting you, but you don't know that, okay? That's it. So this is how I reset. And obviously, um, this is the least likely, least frequently took branch, so that's why this is where I have to have an explicit jump to top. The more frequently taken branch is the inside the sequence, so it's just I'm exploiting saving one cycle by not having a jump here. Anyway, so far so good. The input values are coming in. The preprocessor and the middle guy makes sure that the keeping track of the maximum. This guy, every time it updates the maximum, it sends it down. So what's coming out of this middle node? So every time there's a new maximum, it sends it down. So when do we have a new maximum? Well, obviously when inside the sequence we see a value that is bigger than any previous one, so we're not going to miss the maximum. But also, when we are resetting it, we are sending 0, right? Because we are exploiting this little branch to reset this. So that means if we are sending 0 from the top to reset, we're going to perceive it as a new maximum, so we're going to send it down. So what's coming out is basically a sequence of numbers that are strictly increasing and terminated by a 0, okay? It's not exactly the same as the input sequence because it's just basically the monotonically increasing, strictly monotonically increasing subsequence. Anyway, so what's coming out here is some numbers that are keep increasing, and then we see a 0. So this little guy, this post-processing guy, all it does is, okay, so I keep saving the numbers that you're sending me until I see a 0, and then I send out the last non-zero number that I saved. That's it. That's all it does. Okay, so you send me a number, fine. Let me see. If it is 0, that means the sequence just ended. Let's jump here. Let's pull out the last number that I saved, and that's it. Let's output it. Otherwise, obviously, it's non-zero, so I just save it. That's it. So the insight that allowed me to speed this thing up from around 400 to 256 was this trick of separating the checking of 0 into the preprocessing node and doing the resetting in this sneaky way, such that, and this was crucial, such that the comparison node could use the accumulator for storing the current maximum, so it doesn't have to swap around or doesn't have to do anything tricky. And that's it. But that also meant that since the comparison node itself does not check for 0, it always had to send out the new maximum. And so that's why you need a post-processing one that does the actual outputting of the maximum. This is the one that can detect the 0. Okie dokie. So okay, so this is the maximum path. The minimum path works exactly the same way. The only complication is that the default, the starting value of the accumulator, which is 0, is not good for us because we are trying to find the minimum, and unfortunately 0 is the smallest value among non-negative numbers, which are the values in the sequence. So normally you would just say, okay, I have the same comparison node, but instead of saying if it's less than 0, then jump to max, you could say, okay, just flip the sign. I mean, this node and this node are exactly the same, but I had to flip the comparison. So instead of saying less than 0, it's greater than 0. I mean, that's just a simple trick that when you're calculating minimums or maximums, if you flip the comparison sign, your algorithm we're gonna calculate the minimum instead of the maximum. But you also have to do something with the starting minimum value, which I mentioned to you, 0 is not good. So what I do here is I take as a starting value 100. So 100 is the default value against which we compare other values when we calculate the minimum. This obviously 100 is bigger than any other value, so anything else we see is going to be smaller. So this is basically this first line is just initialization here, right? So what it does, it stores 100 in the accumulator, and then we'll never execute this line again, okay? Because every time we just jump back to the top. So this line is never executed again. I don't really like this, but I couldn't really figure out a better way of doing it. So okay, so this is great. They're just calculating the minimum, but now we have a problem. The problem is that the default value is not 0 but 100. So when we are updating this new min right here, and I'm using the exact same trick as I used before to reset. So if I see a 0 in the sequence, I'm sending down a very small number, so we are guaranteed to take the new min branch, and next I'm just asking you send down the default value that I want to use to reset this little minimum calculator. This is all fine, but the problem is that now this guy is going to send 100 to the post-processing node. So this is the post-processing node for the minimum. So this 100 is not easy to test against, not as easy to test against as the 0. So I have to say, okay, you send me a number, fine. Let me subtract 100, and this is how I check if we are still in the sequence. So if you send me 100, then I know that this is the end of the sequence. So what happens if it's the end of the sequence? I get it back, the last non-zero number that you send me. I have to add 100 because I subtracted 100 here to restore the original value, and that's it. I output it. Otherwise, if it's not 0, I just save it and back to the top. And that's it. That's pretty much it. So as you can see, it just works without any complications. And I'm really looking forward to some insights in how we could speed this up even further, because I really think that some guys got it below 256 just I'm eyeballing this whole graph. Well, anyhow, that's it. I hope you enjoyed it.